Okay, in this video I'm going to continue on with exercise 1E of the book Fundamental Applied Mathematics. We're on page 35 and the question we're going to do is number 9. So this question is actually quite simple, to be honest, so we're going to push through it reasonably quickly. Now the only problem with this is it's phrased, in my opinion, very poorly. So it says, I'll just put it down so we can perhaps look at it. So there's 8. There's 9. So we have two vectors. We have this vector here of minus 7i plus j, and this vector here of I plus j times a scalar. Now this is actually a scalar. So I'm going to call this vector here a and this vector here b. So a is p times I plus j, and this vector here is just minus 7i plus j. So that'll become a bit more clear now when we actually do the question. Just let me sort out my book again now. You can see everything there. Perfect. So, what do we do with all these questions? We begin by drawing our vectors. We have two vectors. We have the vector A and the vector B. The vector A is minus 7 units in the i-hat direction and 1 unit in the j-hat direction. So first of all, we define our unit vectors again, like this. So we're going to call this one I and this one j. Now I'm just after realizing, by the way, why there are three different types of ways of writing a vector. Remember, this could be the vector I, this could be the vector I, and so could this. But remember, unit vectors have a little hat on top. So when you're being introduced to vectors, for some reason they seem to use this notation here. And obviously, like if you wanted to write I hat, that's a bit messy. That's quite a bit messy. So it's always better, I think, to use the notation where you have something, either have j hat like this, and I hat like that, either the straight line or the squiggly line notation. Pick yours. Anyway, like I said, the unit vectors can face in any particular direction. Their purpose is to tell you which axis you're on. You're either going to be on the x-axis or the y-axis. And once again, they could have the unit vectors easily x and y, but they don't. They call them I and j for some reason. So anyway, the vector B is 7 units in the negative y direction, 1, 2, 3, 4, 5, 6, 7, and 1 unit in the positive j direction. So it's somewhere in here like this. And the second vector, vector A I called it, so this is vector B here, and the vector A is 1 unit in the I and 1 unit in the j, so it's something like this here. Now, with all these questions, we resolve our resultant vector A and B into their component unit vectors. And we're already given it. We're told B is 7 units here and 1 unit here. We're told A is 1 unit and 1 unit. So how do you know that's correct? And we know it's correct because, just let's redraw this just for clarity. I'm sure you're well aware of this. If I draw this vector here, I'm going to call it C, and I'll draw this vector here D, and I draw this vector here A, B, C, D, E, and this vector here F. Well, you know that C plus D is equal to A, and E plus F is equal to, I called it B. So you know anyway, we have them in there, we have their component unit vectors. And that was just for clarity. But the thing is, we're asked, basically what we're asked, we're told, we have this vector here, this vector, we call this B, and we have this vector here, A. And as you can see, the magnitude of vector A is smaller than the magnitude of vector B. And it's smaller by a factor. And in other words, if you multiply P times the vector A is equal to the vector B. And they're asking you, what is the value of the scalar P? That's what they're asking. It's just a number. So how do you find that out? It's very simple. You get the magnitude of B, you get the magnitude of A, and you see how many times A fits into B. So B is equal to minus 7i plus j. Therefore the magnitude of B is equal to the square root of 49 plus 1 equals root 50. The magnitude of A is equal to the square root of 1 squared plus 1 squared is equal to root 2. So how big is root 50 divided by root 2? Go square root 50 divided by square root 2, and you see that it's 5 times bigger. Therefore P is equal to P is equal to 5. Check that at the back of the book. And yes, P is equal to 5. So that's the first part. Second part of the question. Find the measure of the smaller angle between these two vectors. Now, as I've spoken of before, but I'll do again, you have to have a reference point when you're measuring angles. Usually they're measured from the positive x-axis here like that. So you go this way. Alright, you could go the other way if you wanted, but they're usually measured from the positive x-axis. So this vector here will say, right, that might be, that's that angle there, and that might be, we'll say, well, what might be 100 degrees. However, this angle here also brings you there. That one might be 260 degrees. Now, obviously, if you say you're measuring all your angles from the positive x-axis, well then it's going to be 100 degrees. If you say you're measuring all your angles from the negative x-axis, it will be 260 degrees. But either way, it brings you to the same position. Clearly, however, this rotation of 100 degrees is smaller than the rotation 260 degrees. So in this question, you're basically asked to find the smaller angle, the measure of the smaller angle between these two vectors. So what are the angles between the two vectors? I'm just going to make this a bit less cluttered. Right, so we have two vectors like this. So we have this angle here and this angle here. Clearly this one here, theta, is smaller than the angle alpha. Alright. So how do we find out the answer? How do we find out their magnitudes? We need to get the value of the two the angles here and here themselves. Right, just to finish this off then, if we look at vector A separately, I'm going to say that the angle here it makes is the angle tau. It gives 1 unit in the j, 1 unit in the I. So to get the angle tau, we use SOHCAHTOA as normal. I'm going to run through this very quickly. So we say, I'm going to take inverse tan this time. So tan tau is 1 over 1, opposite over adjacent. Tau is inverse tan of 1, so tau is 45 degrees. So this angle here is 45 degrees. Similarly, over here, can't really see it, I'll just push across my camera. Do the exact same thing there. Take the inverse tan of a seventh for phi, and therefore phi gives you 8 degrees. Okay, like I said, I'm going to push on this quite quickly. So you have here the two angles drawn. You're asked to find the smallest angle between them. So this one here, we'll say, is 45 plus 82. So this one here is 100. My bio is going 127. You can't actually see that. Oh, I'm sorry. This angle here, either way, is 127 degrees, and that's the smallest angle. The larger angle would be this one here, so it would be 45 plus 8 plus 180 degrees. And that's how you do that question. Thanks for watching. Subscribe to my channel please, and pass it on to your friends.